Hello everyone and welcome to today's webinar on PTC Creo Simulation Live. My name is Alex Janicki, Director of Marketing here for TriStar, and I'll be moderating today's session. I'm pleased to introduce Paul Dye, Application Engineer from PTC's Virtual Center of Excellence. And in just a moment, I'm going to pass the mic over to Paul, but I did want to mention that a copy of this webinar will be available on demand after the live session. If you have any questions during the presentation, feel free to leave them in the chat and we'll answer them after the session. And finally, we do appreciate any feedback on this webinar or topics you would like to see in the future. So along with that recording that's going to be available after the session, everyone who registered will be sent a brief survey. We really appreciate if you can take just a moment to fill it out. It takes about 2 or 3 minutes, but it really helps us out. And without further ado, I'll go ahead and pass the mic over to Paul.
Okay, thank you, Alex. So again, my name is Paul Dye. I'm an application engineer with PTC, and I am in charge of giving overview demos of a lot of our different extensions. And in this case today, we're going to be talking about Creo Simulation Live. I know we're scheduled for an hour today, but we're not going to take nearly that much time. We'll give you some of that time back towards the end, but let's dive into it. Before we get into everything, I just want to take a quick step back and talk about some of the challenges that you might see in the industry today, or maybe some of the ones that our customers have voiced in the past, or maybe even some of the ones that you're seeing in your systems today. So when we look at analysis, it tends to be just too time consuming in the early stages because your models are always in a constant state of change, and your engineers and designers really rely on experience and intuition when they're making those critical design decisions. And that's because we have limited support for any analysis-led design and optimization. And analysis is seen as something that really only the expert can do, and it tends to be more late stage in the development cycle. This really tends to lead to a reliance on late stage physical prototyping and testing, because those prototypes are needed to validate the performance of your design, which really leads to a disconnect and makes two different worlds, where we see one world with design and then another world with analysis. Well, with Creo Simulation Live, we're looking to bridge that gap and bring all those real-time simulation capabilities right into the CAD environment. So this integrates ANSYS technology into Creo Parametric and allows engineers to rapidly explore and start to instantly understand the impact of the design changes that they're making. What we're doing is we're removing the barrier between your CAD systems and your analysis and making one unified modeling and simulation environment. So we're integrating the simulation environment right into the design environment, allowing engineers to see the changes to the analysis that they're making right on top of the model. This was designed to be very easy to work with and works with the common data model. And one thing is this extension was really designed with the designer in mind, not the analyst. So it's a consistent and very easy to work with user interface to set up loads and constraints, very similar to how you would maybe in the Creo Simulate module. Again, we have this now single unified environment for design analysis. So we've taken and worked with ANSYS and taken their Discovery Live simulation engine and embedded it natively into Creo. This allows us to make use of all those different Creo parametric and direct modeling capabilities while seeing the analysis and simulation right on the model. So we've worked with multiple different types of analysis here. So we have linear structural, also thermal and modal analysis. I know in the roadmap going forward where we're looking towards building out on other types of analysis as well. Again, all this analysis changes based off any changes to the model. So any material changes or any types of parametric edits you want to make, just allows for any type of what if scenario. So if I change one part, what's going to be the effect of that? And we don't have to wait around for the results. We're seeing it right on the model itself. This is all completely new technology powered and developed by ANSYS, and we're using that solver engine that actually runs on the graphics card rather than the CPU like we're used to with normal analysis. And this requires the use of an NVIDIA CUDA graphics supported graphics card. And we have a way to check with your systems. We have a link that we can send over to essentially you click on it and it runs and sees if your hardware is going to be good to go. And then on top of that, we do have a minimum of 4 gigabytes of RAM, and then optimal performance starts around 8 gigabytes. So to see what this really looks like and to give you more of an understanding of that, let's see what this type of simulation live is going to look like inside of Creo Parametric. Okay, so one of our partners that we work with often is Polaris, and we're working with maybe one of their data sets here where we have one of their snowmobiles, and we're taking a look at the iron chassis that's going to be on the inside of this Polaris snowmobile. So maybe we're looking at maybe doing a structural analysis on this where we want to take a look at how this works. And to do that, we're going to look at the part level to start with, and then we're going to take a deeper dive and look at how that looks and how that runs on the whole assembly itself. So the first thing that starts with is laying out any materials for the parts we're working with. In this case, we have an aluminum part to this chassis, and then we go through and define some structural parameters. This is going to start with defining constraints by fixing certain surfaces that we don't want to move around. So maybe I know in my chassis assembly, I don't want this bottom bar to be moving around when we do the study. And after this, we're going to select which areas we want to apply our loads to. So I know maybe we're going to have a certain force being applied down on the surface here. And one thing to notice here is, unlike traditional simulation processes, we don't have to modify this part to actually conduct our analysis. With normal systems, you have to go through and take out any kind of rounds or any small holes or interferences. In this case, we don't worry about that. We leave all that stuff right how the part is. All we have to do is go through, define our constraints, define our certain loads and which direction they're going to be placed, and then we're good to go. So now that we have all this laid out, we can go through and click our simulation. And just like that, the analysis is already done. Normally, we might have to wait a long time to get these results back. We're getting them essentially as soon as we click the button. We're getting all this information displayed right on top of the model. We're able to animate that right on top of it to see how that's going to look. Maybe we're more curious in seeing a less exaggerated form of that. We can get a true deformation and zoom in to see what that's really looking like here. So that's really nice to see. We can see that deformation. Maybe as the engineer, I'm worried about a lot of different other things as well. So on top of deformation, we have a lot of different other result types that we can start to look at. So I know that I'm much more concerned with the von Mises stress happening in this part and seeing if we have any certain stressors. And down here, we can see we're getting a certain stressor down here. So what I'm going to do is apply a simulation probe. This essentially allows me to click on different surfaces or parts and get more information on what's happening on that. So now I say, okay, well, I want to make some edits to lower that stress value. It's up at about 55.7 right now. So what happens if I increase that wall thickness? And here I'll just use some flexible modeling just to quickly move out that wall. So we'll click the check and then we'll move back into our analysis. And again, this is all integrated together, and as soon as we make that edit, we're seeing that analysis right on top of it. It's all integrated together. So that's really the idea, is whenever I make a change, I want to be certain that it actually is having an effect. So if I increase the round here on this wall, I want to make sure that that is having an effect on the stress value that we're seeing. And as soon as we do that, we can see it drops down to 49.6 megapascals. So that's really important and something very valuable with our designs. You can see all those different values here right on the model. So the next thing that I want to do is dive into a design exploration. So this is an extension that we have in Creo that essentially allows our users to explore all different types of alternative designs without making any changes or risking anything to the original design or overriding or creating all new types of files. So maybe somebody else on my team sent me this part and they say, okay, Paul, you need to go through and add a trajectory rib on top of this. Well, I know that I don't want my stress values to get too high whenever I'm doing that. So I want to see the effect of adding in something like a rib on one of these faces is going to do. So we're starting at around 28.9. So let's go through and add in one of these ribs. This is, again, just your normal work. Anything that you would be normally doing, this doesn't get in your way at all. It's enhancing the experience. It's letting you know exactly the effects of the decisions that you're making. So we can see as soon as we update that, we can watch that stress value and see how it changes. So we're jumping up to about 32.6. Maybe that's a lot in your study. Maybe that's not that much. Well, now you know exactly what that's doing. So like I mentioned, we can save this off as a checkpoint and refer back to that design decision at any point later on down the road. Okay, so this was very insightful, of course, and we get a lot of information, but I want to see exactly how this type of simulation is going to keep up whenever we run this on maybe something more complex like the entire chassis assembly. So we have obviously a lot more parts going on here, but it's going to start in a similar uh, method as we did before. That's essentially laying out the different fixtures where we don't want this part to move around, and then the study that we want to do with our loads. We have all different types of loads we could apply here. In this case, I want to simulate more of a shaking force. We have a downwards force on the right side here, and then a resulting upwards force on the left. And that's all we need to do, lay those simply out, and then we're going to be good to jump back into another simulation here. And just like that, that's all we have to wait, is just those couple seconds to get these really high definition and immediate results up here. And so normally whenever we'd send a part like this or an assembly like this off to an analyst to get these results back, we'd be waiting hours or days to even start to see some of those. And they have to tell us we're going back and changing something about our design. Well, now we know exactly what it's doing as soon as we make those changes. Again, this is all very visual and we can see everything right in the model and take a closer look in on any part that we want to get more information on. So I see we're getting a lot of deformation at the top right corner here. So let's zoom in here and apply a simulation probe to see how much we're getting. Okay, so we're seeing we're getting about 1 millimeter of deformation. So maybe that's a lot in our study, but we can maybe apply some other parts or increase this assembly and maybe lower that deformation. So I'm going to add in a bit of a support structure to this assembly and see how that value might change. Okay, and as soon as we added those different parts, we see the simulation completely updates. We see that new value right up on the screen there. Okay, and that's the basis of what we're running through with one of our structural studies here. We also have some other options like I mentioned earlier. So let's look into maybe more of a modal study. So what this is maybe we have a certain vibration that we want to take a look at here. Well, it's going to be similar to how we started with the structural analysis and laying that out with those parameters. We can essentially say what parts we want to be fixed and then what parts that we want to study here. Now that we have this laid out, let's go through and simulate this. I want to focus maybe more in on just the chassis. So let's get rid of that support structure that we added in, and then maybe we could add that back in later. All right, so we can see here now, as soon as we click that analysis in terms of the vibration is being looked at here. Maybe we're looking at a certain mode here where we're getting about 60 hertz, and that's our frequency mode, and that's the part that we want to study. So we can see how maybe that's going to be affecting our chassis here. And again, we have different modes that we can look at, and that's going to affect our assembly or our part differently. So if we look at maybe a different frequency mode set, you can see it's more shaking in the backside here. Again, this is all very visual, very easy to look at, and we're not waiting around for these results back. And as soon as we make any kind of changes, we can see how that's going to be updated as well. You see all those values being updated in the legend so we know exactly what types of deformation or what types of stresses we're getting. Right here, we're seeing maybe about 160 hertz. And again, show that deformation. Look at that, really understand it, show it off to other people on your team so they really understand it, and see how everything updates as soon as you make the changes. Okay, so this is a really good look into what we're looking at with the modal study here. And so the next thing that I want to do is just take a quick look over what we're going to be looking at with the thermal studies. So here I have pulled up a engine block, and this is going to be laid out similar to how we started the other ones. So maybe we have a certain convection that's being applied here, where we have each surface laid out in terms of what type of convection coefficient we have, what type of bulk temperature that's going to be touching this surface, and laying this all out before we go into the study. There we go, and we can go in and make any edits, any units if we needed to. And the next thing that we're going to do is apply a load in the form of a heat flow. So maybe I know with my design, this is going to be laid up against a part that's going to be giving it about 100 watts. So let's go through and lay that out here. So now that's going to be applied in the form of a load. We can go through and look and see what this is going to look like when we do our simulation. And almost as soon as we click the button, we have those results up on the screen. So we see what type of temperature values that we're getting all across our part, depending on what type of load that we laid out on here. Again, this is very visual. We can change all those result options to see exactly how we want that to look, hide certain features. Maybe you want to show this off to somebody on our team that likes to see it in composite. Go ahead and lay that out. Anytime that we want to look at that legend, get those values, instantly do that. So again, very quick, very fast, and very insightful with all these different things that we can see on our model. Okay, so moving forward with that, that's really what we have here is the ability to do all these different simulations that normally would have taken us hours or days. We're condensing that into a matter of seconds and allows all of our engineers and our designers and anyone that works with Creo to perform this type of analysis not only early on in the process now, but often and then basically as much as you want. And that's what we're doing. We're bridging the gap between that analysis, which used to be this different world. We're bringing it right into our design environment, no longer separate realms. And at the end of the day, we can get these products out that we're designing much faster and at a higher quality. So that's all I really have to go over with everybody today. So at this time, we can field any questions, or if we're done, then we can head out and give you guys a bit more of your day back.
Excellent. Yeah, let's just hold one moment for questions. All right. I am not seeing any questions. I did want to mention again, there is going to be a survey sent after this. If you can fill it out, we really appreciate it. There is a publication, a handout on PT Creo Simulation Live, and just kind of the some of the key takeaways that you can take with you. If there's any questions that you, oh, here we go. Looks like we got a couple. Paul, do you have a PowerPoint that's like shareable or like a version of this for customers?
I believe that we should have some up on the PTC website. I could maybe look into that, and if we do, we could share that over, and then you could get that out to the people.
Sure. So yeah, I'll be with touch with you after the call. For the person who asked the question, we can definitely send that over to you. It does look like that's probably it. If there's any questions that you guys that weren't answered today, just give us a call or visit tristar.com. And thank you, everyone. Enjoy the rest of your day.